Lesson 8.6 is solving equations. An equation is two expressions that are separated with an equal sign, and solutions to an equation are any values of the variables which make the equation true. A couple tools we're going to use to help us solve equations are the zero product property, which says that if A times B is equal to 0, or any set of products are set equal to 0, then each term can be equal to 0. So A equals 0 and or B has to equal 0. And we use this to help us solve equations that are in factored form. The key piece of this is that it's a zero product property, so it only works when it's set equal to 0, no other number. The quadratic formula says that if you have a quadratic equation of the form ax squared plus bx plus c is equal to 0, then x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. The first type of equation we're going to solve is quadratic equations. In order to solve quadratic equations, we set one side equal to 0, and then there's two methods. First, we want to check to see if it factors, and if it does, we factor and utilize the zero product property. If it does not factor, we can utilize the quadratic formula. So for this first one, we have 3x squared plus 5x equals negative 2, and the first thing we always want to do is set one side equal to 0. We end up with 3x squared plus 5x plus 2 is equal to 0. So now I'm going to see if this factors, so I could utilize the zero product property. In this case, this one does factor into 3x plus 2 times x plus 1. The only thing that multiplies together to be 3x squared is 3x and x. The only thing that multiplies together to be 2 is 2 and 1. And then you just have to figure out the combination that adds up to a positive 5x. So because this does factor, I now have zero product property. I have two products multiplied by each other set equal to 0. So I can just take each one and individually set it equal to 0. So I end up with 3x plus 2 equals 0, or x plus 1 equals 0. And then I just solve each of these individually like a regular two-step equation. For the first one, I subtracted 2 from both sides and then divided by 3 and got x equals negative 2/3. For the second one, I just had to subtract 1 from both sides and got x equals negative 1. So for this one, I always set it equal to 0, check to see if it factors. It did, and so I can use zero product property, set each one equal to 0, and solve. If it did not factor, I would use the quadratic formula. So go ahead and pause the video and try the second one. 3x squared equals 5x minus 1. The first thing I did is I subtracted the 5x and added the 1 to the other side, so I ended up with 3x squared minus 5x plus 1, so it equals 0, so it's set equal to 0. And then I attempted to factor it. The only thing that multiplies together to be 3x squared is 3x and x. The only thing that multiplies together to be 1 is 1 and 1. And then there's no combination that I could make of that would add up to a negative 5x. So I ditched that and I used the quadratic formula, opposite of b plus or minus the square root of b squared minus 4ac all over 2a, where b is negative 5. A is 3 and C is 1. And so then I multiplied everything together. Opposite of negative 5 is positive 5. Negative 5 quantity squared is 25. 4 times 3 times 1 is 12. 2 times 3 is 6. And so you end up with 5 plus or minus the square root of 13 over 6. And then just leave it like that. There's no context, so we don't need to plug it in the calculator. That's just our answer. The next thing we're going to look at is higher order polynomial equations, so something that's not linear or quadratic. At this point, the only way you can solve a higher order polynomial equation without a calculator is if it factors. So you're going to set one side equal to 0, and then you're going to factor it completely, and then solve using the zero product property. So go ahead and pause the video and try both of these. X cubed minus x squared minus 4x plus 4 equals 0, and 9x cubed minus 16x equals 0. For the first one, it factors by grouping, so I grouped the x cubed minus the x squared and factored out an x squared, was left with x minus 1. For the next one, I grouped negative 4x and positive 4, and I factored out a negative 4, and I was left with the x minus 1. So because these two match, they're both x minus 1, that's one of my factors. It does factor by grouping, and the other factor I'm left with is x squared minus 4. The x squared minus 4 actually factors a little bit further. It's a difference of squareds, so I factored that into x plus 2 times x minus 2. Then times the x minus 1 equals 0. So now I have a zero product property. Even though there's 3 products, I can set each one equal to 0, and I ended up with x equals negative 2, x equals positive 2, and x equals positive 1. So go ahead and pause the video if you haven't already done so, and try 9x cubed minus 16x equals 0. For this one, the first thing I notice is that they share an x. I have a 9x cubed and a 16x, so I factor out an x as a GCF. And I'm left with 9x squared minus 16, which is a difference of squareds. 9x squared is the same thing as 3x quantity squared. 16 is the same thing as 4 squared. And so that part factors into 3x plus 4 and 3x minus 4. So I end up with x times 3x plus 4 times 3x minus 4 is equal to 0. So again, 0 product property with 3 terms, just like the one before it. So I have x equals 0, I have 3x plus 4 equals 0, or I have 3x minus 4 equals 0. X equals 0 is just x equals 0. And then these two I solved and I got x equals negative 4/3 and x equals positive 4/3. So at this point, the only way we can solve a higher order polynomial equation is if it factors without a graphing calculator. Later on, we'll learn another method to solve these. The next type of equation we're going to look at are absolute value equations. The first thing you want to do when you have an absolute value equation is isolate anything attached to the outside of the absolute value, so you've isolated the absolute value. So for example, if there was like a 2 being multiplied to the outside of this absolute value, I would divide both sides by 2. Or if there was a plus 5 on the end, I would subtract the 5. So isolate the absolute value expression first, and then we're going to split these up into two different equations. If we think about what it means to be an absolute value, it's a distance away from 0. So if we have some absolute value is equal to 13, that means that we're a distance away of 13 from 0. So we could be 13, which is a distance of 13 away from 0, but we could also be negative 13, which is still a distance of 13 away from 0. So we have to take that into account when we're solving absolute value equations. So for this first one, absolute value of x plus 4 is equal to 13. It's already isolated. There's nothing attached to the outside. So the first thing I'm going to do is I'm going to split this up into two equations. The inside stays exactly the same. I'm just going to drop the absolute value bars. And then the outside, what it's equal to, one of them is going to stay exactly the same, and the other one is going to switch to a negative sign. So we end up with x plus 4 equals positive 13, or x plus 4 is equal to negative 13. Because if you think about what can I take the absolute value of and get 13, well, whatever is inside this absolute value, it could be equal to 13. Take the absolute value of it, I get 13. Or if I take the absolute value of negative 13, I also get positive 13. So this thing that's inside the absolute value, it could also be equal to negative 13. And then I just solve each of these equations like normal. So I subtracted 4 from both sides of both equations. The first one I ended up with x equals 9, and the second one I ended up with x equals negative 17. So now we have another one, the absolute value of 2 minus x equals negative 1. Go ahead and pause the video and try this one. So the answer to this is no solution. Some of you may have gotten that right away. A lot of you may have done this, which is the correct method to solving an absolute value equation, just the incorrect concept a little bit. So you would have done exactly what we talked about up here, which is, okay, absolute value is already isolated. Now I'm going to separate the two. So I'm going to set 1 equal to positive, 1 equal to negative. So 2 minus x equals negative 1, or 2 minus x equals positive 1. I subtracted 2 from both sides, divided both sides by negative 1, and I got x equals 3 and x equals positive 1. Exact same method that we did up here. So where does it go wrong? If I plug in 3, I get 2 minus 3, which is negative 1. If I take the absolute value of negative 1, it's not negative 1. If I plug in 1, 2 minus 1 is 1. If I take the absolute value of 1, it's not negative 1. So what's the issue? The issue is the original equation. You cannot take an absolute value once it's isolated and have it equal to a negative number. Absolute value will never give you a negative number as an answer. So if you ever come across this, it's just no solution. Be careful though, make sure the absolute value is isolated before you say that. The next type we're going to look at is square root equations. So just like the absolute value, we're going to isolate the square root first. If there's square roots on both sides, you may have to do this twice, but isolate the square root and then undo the square root. The key piece on square root equations is we always have to check for extraneous solutions. So go ahead and pause the video and see what you can do for this one. So I isolated the square root by subtracting 2 from both sides, and I got the square root of 2x minus 3 is equal to 5. So to undo a square root, I squared both sides and got 2x minus 3 is equal to 25. And now this is just a regular two-step equation, so I added 3 to both sides and divided by 2 and got x equals 14. But with square root equations, you always have to check for extraneous solutions. An extraneous solution is a solution to the problem in the way that you solved it, but it's not a solution to the original equation. So I'm going to plug 14 into the very original equation and check to see if it actually does work. So I have 2 plus the square root of 2 times 14 minus 3, and I want to know, does that equal 7? So I end up with 2 plus the square root of 28 minus 3, which is 2 plus the square root of 25, which is 2 plus 5, which is equal to 7. The reason we have to check for extraneous solutions with square root equations is this step right here. When we square this equation, we go from a square root equation to a linear equation. And in a little bit, when we start talking about functions, we're going to talk about the domains of these functions. And square root functions have a very different domain than linear functions. So that changing of the equation can cause extraneous solutions. So make sure you always check your solutions when you do square root equations. The last type that we're going to look at is literal equations. Literal equations are equations that have multiple letters in them, and maybe no numbers at all. Sometimes yes, sometimes no. The key piece when you're solving literal equations is you want to isolate whatever variable it's asking for. Everything else gets treated like a constant. It gets treated like a number. So if it's being multiplied by the variable that you're looking at, then you divide by it. If it's being added, you subtract by it. It just doesn't necessarily combine nicely like terms does. So we have this equation A equals P times the quantity 1 plus RT, and we want to solve this thing for R. So go ahead and pause the video and try that. There's a couple of different ways you can solve this one depending on what your first step is. For me, I divided both sides by P first, and then I subtracted the 1 and divided by the T. So my first original one looked like R equals A over P minus 1 all over T. Another common option is to distribute the P, so you end up with P plus PRT on the right side, subtract the P from both sides, and then divide by PT, so you end up with R equals A minus P over PT. Another equivalent solution, if you were to simplify either of these, you would get A over PT minus 1 over T. Those are all equivalent solutions. So there's different ways you can kind of solve them, and your answer may look a little bit different, but they're all equivalent solutions. So this has been solving many different types of equations. The key piece is knowing what type of equation it is and what method you're going to use to solve that type of equation.